We're going to go into lesson 4.1, which is identifying and graphing sequences. And we'll start with a couple of vocab words here. It says a sequence. This is just a list of numbers. This could be any list of numbers here. It doesn't have to have a pattern, but it could have a pattern. So this could be anything. I'll zoom in a little bit here. This could be anything like this. 2, 6, 10, 14. We can see that one has a pattern, but a sequence doesn't have to have a pattern. It could be totally random. So -1, 3, 37, 41, and so on and so on. So a sequence is just a list of numbers, and then it says term of a sequence. That's just going to be each number that's listed in the sequence. So if I had some sequence that looks like this, 2, 4, 6, 8. Well, the first term would be right here. Second term would be right here. Third term and fourth term, and it would go on and on and on. And some notation we use for that. The first term we would call A1 or F1. So A with the parentheses 1, right? Then the number 6 would be A3, and so on and so on. All right, it says describe the pattern in each sequence. What are the next two terms of the sequence? This should be pretty straightforward. Okay, so we can see with letter A, it looks like we're going up by 3, right? So we're increasing by 3. And so the next two terms would just be 17 and 20. Okay, letter B, it looks like we're doubling there, right? So 2.5 to 5, that's multiplying by 2, and then multiplying by 2. So the next one would be 40. And 80. Letter C looks like we're increasing by 6. So the next one would be 29 and 35. Okay. Letter D gets a little bit trickier here. Okay, for letter D, it looks like we're multiplying by 2, but it's going to be a -2 because we can see that the signs are alternating here. So this is actually going to be, let's see, -2 times -16 turns into positive 32. And then if I multiply that by -2, I end up in -64. And we'll keep moving here. Letter E, looks like we're going up by 5. So the next one's going to be 23 and 28. Letter F, let's see, we go from 6 to 9 to 13 to 17. So we're increasing. It doesn't look like we have a pattern there because we're going up by 3, and then we go up by 4, and then we go up by 4 again. Let's see, so it doesn't look like there's no pattern there. And then we move to letter G here. So it looks like we're decreasing by 6 in this one. So this next one would be -14 and then -20. All right, so hopefully that was pretty straightforward there. Now we're going to get to this stuff that's a little bit trickier. It says generating sequences using an explicit rule. So an explicit rule is just going to be some sort of a formula, some sort of an equation that's looks like over here. And the key with an explicit rule, which is outlined in this box on the right, it says an explicit rule is a rule or a formula that allows us to find any term in a sequence. So the nice part about this rule here is as I start to plug in numbers, it's going to generate some list for me, some list of numbers, right? If I plug in 1, it's going to give me an output. If I plug in 2, it gives me the next output. If I plug in 3, it gives me the next output, right? And eventually I'll have a list of numbers here as I punch in things for n, right? And the thing is, if I want to know what let's say I want to know what the 50th term in this sequence is, right? So all the way down here, the 50th term in this sequence, well, I can just plug in 50 for n, and it'll tell me what the 50th term is in that sequence. And that's the nice part about these explicit rules. If I wanted to know the 110th term, I would just plug in 110, and it would give me the 110th term in my list of numbers. All right. Luckily, we don't need to find all of those. We just need to find the first 4. Okay, so I'm going to go ahead and find the first 4 terms in the sequence. So to do that, I'm just going to plug in 1 to find the first term. So if I plug in 1, that's going to give me 1 squared plus 2, okay, and I get an output of 3. And then I just keep going here, so f of 2, that's going to be 2 squared plus 2, so that would give me 6. 2 squared is 4 plus 2 is 6. Okay, and I just keep moving here. So f of 3 it's going to be 3 squared plus 2, which is going to give me 11. And then f of 4 is going to be 4 squared plus 2, which is going to give me 18. And so the first 4 numbers in my list here would just be 3, 6, 11, and 18. And so I'll go ahead and list those over here. That was 3, 6, 11, and 18. So that's 1, 2, 3, 4, right? And this keeps going and going and going here, but it only asks me for the first 4. All right, it's moving on to letter B. Okay. Letter B is asking the same thing, gives me a different rule here, a different function. So I'll go ahead and start to plug in here. So f of 1, let's do this. So f of 1 is going to be 3, and then 1 squared plus 1. And I wanted to go through this part with you because it gets a little bit trickier here. So remember, order of operations means we have to do the exponent first. In this case, that's going to be the 1 squared. So when I go ahead and do 1 squared, well, 1 squared is still just 1. So this is going to leave me with 3 times 1 plus 1, which just gives me 4. Now we'll do f of 2. So that's going to be 3 times 2 squared plus 1. Once again, we got to use order of operations here to do 2 squared. So 2 squared gives me 4. So this is 3 times 4 plus 1. And that will give me a 12, 13. And I'll keep going here, f of 3. So I get 3 times 3 squared plus 1. And that's going to be 3 times 9 plus 1, which is 28. And then f of 4, that's going to be 3 times 4 squared plus 1, which is 3 times 16 plus 1, which is going to give me a grand total of 49. Okay, and so notice please on these, right, I'm not multiplying these two numbers together first, so I didn't do 3 times 4 and then square it. I just squared this number first, and then I multiplied by 3, and that's the order that we have to do that in. And so the first 4 terms in this sequence would be 4, 13, 28, and 49. Those would be the first 4 terms, right? Remember, if I wanted, like, let's say the 51st term in this sequence, then I could just plug in 51 for n, and it would give me the 51st term in the sequence. And that's exactly what it's asking here. It says, how would you find the 20th term in the sequence? Okay, well, the answer to that is just plug in 20 for n. Okay, let's scroll down to letter D. It says, if the number 125 is a term of a sequence defined by this rule, which term in the sequence is 125? Okay, so for this one, it's asking me which term is this. So basically, they're asking me this question backwards. It says, if the number 125 is a term of the sequence. So we have these terms in our sequence, so I'm just going to put these blank spaces here. And then somewhere along this, we have 125, right? And it wants to know, okay, well, what number is this in the list? All right, so we're kind of working backwards here a little bit. Remember, when we're trying to figure this out, okay, we have to determine, well, if I wanted to find let's say the fifth term, I would plug that in for n. But this time, I'm looking for 125. That's the number in the list, so I'm going to plug that in for f of n on this side of the equation, and then figure out which number this is in the list. So I have this set up here. 125 equals 3n plus 2, because I'm trying to figure out which number in the list this is. Okay, and then I just have to solve this here, so I'm going to go ahead and subtract 2. I get 3n equals 123. Okay, and then I'm just going to go ahead and divide both sides by 3. And I'm going to end up with n equals 41. So this would be the 41st term in my sequence, right? So I would need a lot more dash marks here, okay, because this is the 41st term in my sequence. All right, we'll keep moving here. We also have these rules that are called recursive rules, okay, and they get us to the same place as the explicit rules. It's just a different way to do it, and really it's a less helpful way to do it. Okay, it says a recursive rule is a rule or formula that allows us to find the next term in the sequence. Okay, so the bummer about the recursive rule is it only goes one term at a time. So I couldn't just find it, say I needed the 51st term, right? 1, 2, 3, 4, ... all the way down here. I couldn't just find this by plugging in 51. The recursive rule only works in that I have to find them one by one. So I have to find these in order one by one by one. Okay, and so it takes a little bit longer. It's not quite as helpful for us in this type of math, but it has other uses that you might get to eventually in your math lives. So you kind of have to go one by one here with the recursive rule. So check this first one out. It tells you that f of 1 is 4, and it wants you to find the first 4 terms here. So it's telling you that the first term is 4, and it wants you to find the next 3 terms here, and then it gives you this information. Okay, so it tells you to find f of n, it equals f of n minus 1 plus 10. So really what I want you to focus on here is that this f of n minus 1, this piece, which is always pretty tricky, this is where we have a lot of trouble. Okay, this f of n minus 1 just means this number here. So the f of n minus 1 just means that number there. So to find this next term, all I have to do is just do 4 plus 10, and then it gives me 14. And then I need to do 14 plus 10, and it gives me 24, and then 24 plus 10, and it gives me 34. Okay, and those will give me those next pieces. So if you didn't grasp it there, check out this next one. Same deal, we're looking for the first 4. It tells me f of 1 is equal to 2, so that's the first term is 2. Okay, and now what I'm going to do is, where this f of n minus 1 is, I'm going to plug in 2. So it looks like this. 3 times, instead of f of n minus 1, I'm going to put 2 and then plus 6. And so that's going to give me 6 plus 6, which is 12. And then we just repeat the process, right? So the 3 and the 6 stay where they are. We're just replacing this f of n minus 1. So we just continue to repeat this process. 3 times 12 plus 6. And that's going to give me, let's see, 3 times 12 is 36, plus 6 is 42. And then one more time, 3 times 42 plus 6. And then again, we can just go 3 times 42 plus 6, which gives me 126 plus 6, which is 132. All right, we'll keep it moving here. One more time. Wants us to find the first 4 terms. 1, 2, 3, 4. It tells me f of 1 is 2, so that means the first number there is 2. And then once again, I'm going to plug this in for the whole thing. F of n minus 1 gets replaced here, so it's going to look like this. 2 squared, which is going to give me 4. And then I'm going to plug in 4 and square that, which is going to give me 16. And then I'm going to plug in 16 and square that. Right? Remember that's 16 times 16. So maybe some mental math, maybe a calculator there. It's going to give me 256. And I'm done. Okay. Let's check out this next part here. It says a gym charges $100 as a membership fee and $20 monthly fee. Use the explicit rule f of n equals 20n plus 100 to graph the sequence. Okay, so they're starting me off with the rule here. This is the explicit rule, so I can find any number that I want. And I'm just going to plug in these numbers one by one here. So I'm going to start with 0. Okay, so if I go to this gym for 0 months, then it's just going to be 20 times 0 plus 100, which is going to give me 100. So I have 0, 100, so that's going to be right about there. I'm putting it on the graph. Okay, and I'll plug in a couple more here. Let's say I go there for 2 months. F of 2, that's going to be 20 times 2 plus 100, which is going to give me 140. So that was for 2 months. So I'm over here at 2 up to 140. Okay. And then I'll plug in 4 here. And remember, you can plug in whatever you like, right? I'm just picking some domain values, some inputs here. 20 times 4 is 80. 80 plus 100 is 180. So that was 4, 180, and we're right there. All right. And that's it. So thanks for watching.